Assalamualaikum dan apa khabar semua? Selamat datang ke channel saya, Cikgu Hasnita. So previously in generation and transmission of electricity part 1, we have discussed how the electricity are generated from various sources of energy by applying the same mechanism called electromagnetic induction. And for today, we are going to look how is this electricity which produced by the generator is transmitted from the power plant to the consumer through an electrical cable or transmission line for the distribution in industries, offices, and homes. To understand how the electrical transmission are done, let's take a look at this animation. The bulb on the left side represents the power plant, while the one on the right side represents the consumer, while these are the transmission line which connect both. So let's observe what happened when I switch on this button. Alright, you can see now both bulbs are light up, but the one on the left, which represents the power plant, light up brighter, while the one on the right, which represents the consumer, light up dimmer. Why is this difference occur? So this is because as the electrical energy passes through the transmission cable, it generates heats in the cable. This is due to the resistance of the cable, and some energy are lost in a form of heat. So when there is an energy or power loss during the transmission, what will happen to the amount of current flow to the wire? So to know the answer, let's take a look at this study. So let's take the resistance in the constant wire as 1 ohm. So we are going to look what will happen to the amount of power loss when I adjust the amount of current flow to the wire. Okay, let's begin with using a current of 0.1 ampere. So it said here that the power loss will be 0.01 watt. How to get this? To determine power loss in electrical cable, it is given by P equal to I squared R, where P is the power loss, I is the current flow to the cable, and R is the resistance of the cable. So now I adjust the current to 1 ampere. Okay, so the power loss now according to the formula will be 1 watt. Then I convert into 2. So now the power loss will be 4 watt. When current is 4 ampere, the power loss is now 16. And when I set the current flow to 8 ampere, the power loss will be 64 watt. So these are the results of the previous experiment. So what can we understand from this result? It shows that when a current flows in a cable, there will be a power loss due to the heating of the cable. And the value of the power loss are determined by applying P equal to I squared R. So the conclusion from this study, we understand that a small difference in a current makes a huge difference in an electrical power loss as heat. So how to overcome this problem, how to reduce power loss during electrical transmission so the current is sent at a lower value. How to do this? By increasing the transmission voltage with the help of a transformer is sound to be the best options. Okay, now let's take a look at this example on what is the effect on increasing the transmission voltage on the power loss. A 10 megawatt power plant delivers electricity to a town via cables with a total resistance of 100 ohms. Estimate the power loss in the cable if the electric power is transmitted at A 100 kilovolt and B 200 kilovolt. You are given with a power generated where P is 10 megawatt. and the resistance in the cable is given R 100 ohm. So how to find the power loss in both a situation? First, we must find the amount of current flow. So how to find the amount of current flow? It is get from this equation I equal to P divided by V. So P is 10 megawatt divided by the voltage at A, which is 100 kilovolt. So the current flow will be 100 ampere. And to find the power loss, we are using equation of P equal to I squared R, where I is 100 ampere and the resistance of the cable is 100 ohm. So the power loss will be 1 times 10 to the power of 6 watt. And for B, when the voltage is applied at 200 kilovolt, which is higher than A, again, we find the amount of current flow in the cable first. So how to find the current flow? I given by P divided by V. So the power generated is 10 megawatt divided by the voltage 200,000. So now the current flow in the cable is lower, which is 50 ampere. Hence, the power loss will be, again, apply P equal to I squared R. So it will be 2.5 times 10 to the power of 5 watt. So we have worked on how, by transmitting the electricity at low current but high voltage, we're able to reduce the power loss in the cable. Okay, now let's take a look at this diagram. It shows a network of transmission lines which called as a national grid network, NGN. So what is NGN? National Grid Network is a network of transmission line which link all the major power stations in the country with all consumers such as homes, offices, cities, and factories. At the power station, electricity are generated at 25 kilovolt, and this 25 kilovolt need to be higher up in order to reduce the power loss during transmission, and this is done by the step-up transformer. Since the transformer only works with AC, so an alternating current is used for long-distance power transmission. So the step-up transformer will increase the output from the power plant from 25 kilovolt up to 132 kilovolt. So this 132 kilovolt enter the electric pylon, and before it reach the consumer, again it has to be lower down. So this is where the step-down transformer play their roles. For example, a heavy industry require 33,000 volt to operate, while 11,000 volt need by the light industry, 415 volt by the offices and buildings, and 240 volt for houses. So it seems that we have come to the final part of today's lesson. What are the importance of the National Grid Network? A National Grid Network is to ensure that the transmission of electric power is, number one, efficient, where it uses a high voltage for power transmission in order to reduce the power loss. Number two, reliable, in which enable an active rerouting in the case of failures at any stations. And number three is cost effective, where it enables a less efficient power plants to be shut down during and off-peak hours. Alright, so it seems like a very long story, but I hope you will enjoy this lesson. And again, before I say goodbye, let us do the checking on what are those knowledge you should achieve after following this lesson. Number one, when a current flows in a cable, the power loss through the heating is given by P equal to I squared R, where R is the resistance in the cable. And the heat losses can be minimized by decreasing the current in the transmission cables. Number two, to transmit a given power, P equal to VI, the current can be decreased only by compensating with an increase in voltage. And last but not least, A high voltage power line are used to transmit power over a long distances. So join me again in the next lesson for more physics updates. Till then, thank you for watching and have a great day. Bye.